Some people have asked me lately if polyatomic ions have ionic or covalent bonding, and the answer is be more specific. Within each ion, there's some covalent bonds. Like what's holding the N's to the H's here? Each of these things is covalent. I'll even write that here. Whoa, marker broke. Sucks to be me, eh? These things are covalent bonds. I know that in this case because nitrogen and hydrogen are both nonmetals, and I know that they share electrons. And here in the nitrate ion, these are covalent bonds as well. But what actually holds NH4 to NO3 in the big lattice structure? The answer is that this unshown bond here is ionic. I hope that's not a surprise, because this is a positively charged ion, and this is a negatively charged ion, and it's held together with an ionic bond. But again, within each ion, it's covalent bonds, generally, unless you have a metal in the center, which is rare. But I don't want someone getting at me in the comments that I'm wrong. Here's another example. We got sodium carbonate. You got sodium ions that are plus charges, and you got a carbonate polyatomic ion with a 2- charge. We need 2 pluses to cancel out the 2- here. But what we have is an ionic bond holding the Na plus to the carbonate, and this is an ionic bond as well. They're ionic because it's between 2 ions. It's between a plus and a minus. Not a surprise. But again, what's holding the carbonate together as a CO3? Well, these are both nonmetals, carbon and oxygen. So each of the things I've circled here are covalent bonds. So there's covalent and ionic bonding depending on what you're being asked. This is carbonic acid or hydrogen carbonate. Now here, the carbonate 2- is countered with 2 H pluses, or H plus 1 charge things. Now these are actually all nonmetals, so in this case, it's actually covalent bonds everywhere. There's no plus or minus charge to speak of, although you could probably argue that you have H pluses bonded to a CO3 2-. H plus, I don't know why that's a bad habit of pH. You could probably argue that there's ionic character to those bonds, but we generally say nonmetals are covalent bonds. So this is an example of a polyatomic ion that is not forming an ionic bond, even though it did up here when we used a metal. Yeah? So like I said, it's complicated. The fast answer is within each ion is covalent bonds, generally, and what's holding plus and minus charges together is always going to be an ionic bond. Capiche? Yeah, that's right. Best of luck.